we're getting there with the with most of the content. So we have one more week's lecture, and then we're into the break. We have a test when we come back. The test is on the Friday of week 14, and then the coursework is on the Monday after week 15. Okay, so make sure that you know your schedule over the break. I'll be on the Slack space if you need to ask any questions. But if you've got any questions, ask them in the lab today about the coursework and so on. So hopefully you've been looking at the coursework, you've been thinking about which area that you would like to do, you maybe looking at some research papers, you've downloaded some GitHub code, you're thinking about the experiment that you might run, and so on. Okay, so if you have any questions, then please ask. The last thing you want to do is to come back after the break and not know where you are with it. I'd prefer Overleaf and LaTeX, and I've got some demos of that, but it's up to you. You can still use Word. I'd like a GitHub if you could, but that's fine too. So have a think about that. I'll be releasing the study guide for test 2 quite soon. You should all have your marks now, and you should know where you are in the module, whether you have to work a bit harder, or maybe even a little bit less. You should know roughly where you are, where you want to be, and probably how you should be studying for the next test. Okay, so that's where we are. We've done 30% of the assessment. You've still got 70% of the marks to pick up. So there's still lots of scope for you to achieve the grade that you're really looking for. Does anybody have any questions on where we are just now, what we're doing? So hopefully now we're in the closing straight, and it should all come together, hopefully.
Next week, you previously it was 2 weeks post-security.
That's right. So it's now called Tokens, Authorization, and Docker. So we have another one of these next week, and then we'll go into our break. Okay. So I'll give you a study guide that outlines what we'll be studying in the second test. Okay. So that's where we are. That's where we're going, and hopefully it's all coming together and all making some sort of sense. So for this week, we're going to try and understand where we are now, where the weaknesses are, and where we're going for the future. Like it or not, much of the architecture that goes on, much of the security is now happening up the layers. It's to do with tokens, it's to do with authorization, it's to do with rights, and so on. So today we'll have a look at what tokenization really means, what authorization tokens are, how they can be used, how you can make sure that users only have to sign in once. But once they do that, you're opening up a whole can of worms. Your user might now have a ticket for an hour, and they can do whatever they want, and they can pass that token on to lots of systems across your network. If that token gets stolen by someone, especially if it's an admin token, your whole of your network infrastructure is now open. And developers, unfortunately, like to get things built and likes to get things working, and it's great. Look, a single sign-on, isn't that amazing? Look, you don't have to log into the different systems, but you'll actually find that that's probably one of the weakest areas. In terms of the OWASP top 10, authorization is the number one thing. So we need to understand really the scope of tokens, how they're used, and how we can tokenize our data. So with this, we'll have a look at ECR20 tokens. So I'll let you have a look at what those look like. And then we'll go into JSON tokens, JWT, and see what the weaknesses are of that. In the lab today, we'll be creating some JWT tokens, and hopefully we'll be cracking them and showing how it's not too difficult. Well, Chrome gives them away, basically. Whenever you have a JWT token, you just look in Chrome, and there is your JWT token there. It's not a big secret, okay? So don't think that all those tokens that you create are ever a secret. Your browser knows them, and your browser will reveal them. And then we'll look at the disaster area. There is OAuth 2. There has seldom been a time that a specification went from version 1 to version 2. It lost functionality, it lost security, it lost virtually everything. But it became a standard because who's pushing it? Google. If Google pushes a standard, then that standard is likely to stand. So OAuth 2 is one of the biggest disaster areas in computer security. And it's because it's so simple. It's magic. I create a token with OAuth 2 and I can get access to all my infrastructure. Wow, that's fantastic. Does it have signing? No, it doesn't. Does it have crypto? No, it doesn't. So how can you trust anything that's revealed through an OAuth 2 infrastructure? If you go and work for a bank, you'll find that they use different. They'll use what's called SAML, which is actually quite a difficult language to implement, but it is a better implementation of a rights infrastructure. Then we'll look at some Fernet tokens, how you can easily create an infrastructure which encrypts data and properly signs it. And then on to what's called PAKE, which allows us to be able to store a nonce for the user's password, and then for the user to be able to authenticate that they still know their password, and you're not at risk of the password being hacked. And then finally, it's one of our favorites, is Docker. So we've been through setting up servers, and then we set up clouds. So we set up our VMware infrastructure. It's magic. It runs really well, as you know, but it's really complicated. Docker is an amazing new technology which containerizes. Why do I need to run on a big cloud system? Why don't I have a whole bunch of computers running Linux, and I can run SSH if I want? I don't need the full Linux Windows infrastructure. I just want to run an SSH infrastructure. I can just create a little Docker container for it, and that's it. And the great thing is that I can script it, and I can script it. And now with Kubernetes, Kubernetes came along, and it's magical, creates clusters and creates whole worker farms. So when everybody logs in at 9 o'clock in the morning, Kubernetes said, yeah, I'll need a lot more servers and things like that, so let's kick them in and come on, all use cluster nodes, spin up now, get ready for the work, and then when all the work is gone, they go, well, you're finished, you go back and do that there. So Kubernetes is really taking over greatly, and you'll find that many companies are now using it to build their dynamic infrastructures. It deals a lot with security too, and it will do a lot of the firewalling and so on, but you've really got to watch if you've got any flaws in there, you can cause a lot of problems. Okay, so in the lab today, we'll do some Docker, hopefully, and we'll set up things that we set up before, but now we'll do it in a Dockerized container, and we'll script more. We can create our whole infrastructure with Python or Node.js and get it all to work and get rid of it and then deploy it somewhere else. So it's a big move in the industry just now, and Amazon and especially AWS is moving towards this containerization infrastructure with Kubernetes. Okay, so how do we get into systems? How do we authorize? Tell me some of the methods that you use to be able to get into a system and get rights. Yeah. Username, password, login, that's the traditional way. Doesn't scale very well, and we could have to log into different systems. Okay, so that's the weakness of that. So how else do we sign into systems and get authorization? One-time password. So a good way is now with a one-time password, so we can set up with, say, a YubiKey or something like that, so that the ID comes up, and especially within the Google Cloud and so on, if you want to get access, you might log in, but out of band, you'll get your little code that's a one-time password that might be timed too. So increasingly that's good, because you could actually say that all I need is a PIN number now. In fact, all I need is a little secret that I have. I don't need my username and password anymore. I just provide something, and then out of band, I now get the one-time password. Any other way? Biometrics. So increasingly we're using biometrics to be able to access systems and then to be able to get the rights across it. Do you know what happens in Napier when you log in? What generally happens when you log in to Moodle? What appears first? Single sign-on. Okay. So single sign-on is magical. Don't we love single sign-on? It's a single point of failure. Of course it is. But now you have a magic key. You have a magic key. If somebody discovers your username and password or does something underneath, you now have access to the whole of the infrastructure and can now move around. So how will we limit that problem? So if I now have a one-time, if we have a single sign-on, how are we going to limit the possible damage that might have? Yeah, so let's say we're in and everything's fine. So we have multi-factor. Hopefully in most companies that you'll be in, there'll be a multi-factor in there. What kind of multi-factor would you do in terms of that login? What's quite a smart thing to do? IP address is obvious, whitelisting IP addresses, so you're not allowed to log in from these bad addresses. What else? Well, blacklisting is difficult because there's too many to blacklist, and an address might appear. So you would open up a whitelist. Let's say you know your workers are at these IP addresses, and your organization has a certain range. So that would at least lock that down. And if you want your users to log in through a VPN, then it will give the IP address of your organization. So you would generally whitelist.
Yeah.
What other methods might you have?
Impossible distance algorithm for like geolocation caching.
Yeah.
That like someone can't be in two places at once.
That's right. Yeah. So you would look at some sort of location tracking. IP to location is one, but that doesn't work. I come up as Winslow just now with my my Twitter feed. So it's obviously a resolution that isn't in Edinburgh. So it's not that great in terms of IP mapping. If you can do GPS, that's great. If you can do time-based, your users aren't allowed to log in at 3 o'clock in the morning and so on, then that's obviously one way that you do it. So you need to limit the time of that authorization and you need to take them in at the lowest level. So the token itself should have some idea about what rights that you have. Unfortunately, with role-based, you tend to have staff, student, admin. You need more levels of escalation because you're now accessing all your systems, including your HR system and so on. So try not to have simplistic role-based security. You add in attribute-based security. Attribute-based will say that a locum in a hospital is only allowed access to the system between 5 o'clock and 12 o'clock. That's an attribute of the token that you would grant them. At 12 o'clock, they don't have any access rights anymore. I've been into hospitals and I've seen it. On a Friday evening, there's a bunch of logins for the network, and the locums come in and they go, yeah, I'm a doctor. Can I have the access details? And it's fairly easy for them for that to be spoofed. So if possible, try to lock your system down so that it's not just role-based, but there are also attributes in there. It's not an easy thing to do, but your policies should be based not only on you and your role, but also on the attributes, where you are in the world, where how you're accessing, and so on. So we have many ways that we can lock this down. But increasingly what we're doing is using tokens. And we're defining our domain and the scope of the token, and then that token is then passed through each of the services that we use. And we'll see there are terrible practices involved in this. So one way that we obviously do it is that we connect to a Windows domain. So like it or not, it's likely in the place of work you'll be dealing with Active Directory and Windows domains. You also have your Linux server infrastructure. So you need to learn Windows to be able to understand how Active Directory works, because that's the default. HR departments love Active Directory. It gives you your corporate infrastructure and so on, and locks down each of the machines. So within a corporate infrastructure, each machine has that identifier. And in here, you will actually identify the domain which you run. And it's so important that you don't have one domain controller, you have many. Because if it falls over, you have nothing. So none of the machines can really be accessed unless the domain controller is there to take over the rights of the machine. So you have a primary domain controller and a secondary one. And increasingly in the cloud, in say Azure, you actually have your whole domain Active Directory infrastructure in the cloud. And many companies are moving from a domain controller on their site into the cloud. It's a big service. It's one of the biggest things that Microsoft have. It's really kept Microsoft at the forefront, the whole Active Directory domain infrastructure. So that's what it looks like, and then all of you users, if this is a domain controller, all of the users have a unique ID, and then once your machine logs into the domain controller, then domain controller takes over the rights for that machine. So what we end up with is a domain controller and a whole lot of hosts that are then locked into the to the controller. And as we saw last week, what we're doing is increasingly using tokens. And the good thing with using tokens is that we can have our back-end infrastructure where we can keep all our personally sensitive information, our passwords and so on, behind some sort of exchange. So as we saw, we take a token, we put it into data processing infrastructure. If we need to resolve it, we put it into a tokenization infrastructure and do some queries on it, and then get replies coming back again. The tokens themselves, we've got to make sure they aren't crackable, They can't reveal anything about the information that we actually have. So this is the way that Visa defined a tokenization infrastructure for finance. We'd have our token generation, token mapping service, our vault for all the sensitive information, and then some sort of key management system. So this is the way that you would want to sort of create a tokenized infrastructure. So the use case we looked at was that Bob asked for a token from the tokenization service. He passes that through to the merchant, onto his bank, and then into the tokenization service. Tokenization service has all his account details and responds back to say that Bob has enough money in his account to pay for the goods. And the good thing with that is that this tokenization service can respond back to Bob to say he's just bought something. But we don't reveal his CVV number because it's a fake CVV number. So if somebody tries to play that back with his credit card details, then it won't work at all. So that's the way that banks are moving towards at least hiding, tricking the existing system that you're not going to rip up. You can't just change your whole point of sale and the whole back-end network. So you need to find ways to trick it into thinking that it's dealing with the real data. So the first area, and this is likely to be the way the internet will go. So why can't we trade with some sort of electronic token? So when we buy things, when we own a car, we have a bit of paper that we sign and we send the details in. Why can't we have a token which we own in an electronic wallet? Then, if somebody wanted to see that if we owned that asset, we would show them in our wallet the token that related to it. If I wanted to sell it, then I would give the token to you. So let's look at an infrastructure. So one of the most developed is Ethereum, as we saw. And Ethereum is there to produce these dApps. And the dApps are there to run smart contracts. And what they should do is create trustworthy infrastructures. So in a dApp, we can create money. We can magically create money. So with ICOs and with XRP tokens and so on, you could all, tomorrow, create a smart contract on Ethereum and create your own token. Unfortunately, it's unlikely to be worth anything unless you actually promoted it with a service. So if you said we're a window cleaning service and you want to buy my tokens, then you might be able to trade them with other people for window cleaning. So with this, we can actually create tokens that can be stored in wallets. And then we can share them, transfer them, and obviously store them. So what's required whenever you create your token offering is that you define your total supply. So you would define the total number of tokens that you're releasing to the market when you create the initial offering. Then it's the balance that you have for each user. So initially you'll own them all, but then eventually people will buy them or you'll trade them, and then the Ethereum will know who's got what tokens in there. The transfer from, and then there's an approval, and then an allowance. So these are the standard parts of an Ethereum smart contract that you have to define. Then you have an optional thing. You're going to call your token a certain name so that people can actually find it. You're going to give it a symbol, like Bitcoin's got a symbol in there, and then you might have a number of decimal places that you've got for defining your cryptocurrency. That will be the smallest amount of your currency that you have. So for this smart contract here, so there's an example of a smart contract. It's running on Solidity, as we've seen. It's building on the standard contract. So there are standards in Solidity for contracts already prepared, and what you're doing is updating it with your little bit. So in this case, we're actually defining that we have a bear token. That's what it will be actually known as in terms of its symbol that it's going to have. Its name is a bear token. We're going to have 5 decimal places for it, and we're going to release 100 billion tokens onto the market. So they're now there sitting to be traded. So if I show you my wallet, so just let me make sure that it's not showing anything here. So if we look at my wallet here, so I can trade with ECR tokens. So I can receive them if required. If somebody wants to send me this type of token here, this is an ECR20 token. So once I've registered, say, somebody to receive it, I would just add them to my wallet. Be a matter of just clicking here. I don't have anybody on there just now. Or you could actually find the hexadecimal address if you want to take your time in typing that in or copying and pasting, and then we'll actually define the amount or the cryptocurrency or the tokens that would get sent. Okay, so in this way we can become millionaires or billionaires. The guy who looks after Ripple, do you know the cryptocurrency for Ripple? It's not associated. Ripple is a kind of protocol. It's not a cryptocurrency, but they release XRP. Oh, sorry, I've given away XRP. It's one of the top ones. I think he became one of the richest people in the world for a while because XRP was worth a lot of money. I don't know if you noticed, Bitcoin has jumped. They reckon it might have been an April Fool that triggered that. I don't know if anybody read that, but there was an April Fool that said that 2 security exchanges were adopting it in the US, and so something's happened to Bitcoin. So it's a crazy world. Okay, so then I run that. Truffle is a package that allows you to run smart contracts. You would run that into Truffle, and that would be it. You'd be all going, and you'd have to tell the world that you now had an ECR20 token. If the supply is good, if the demand is higher than the supply, then your cryptocurrency goes up. But if it goes the other way, then it's on a downward spiral. So it's up to you to make sure that you have something that people actually want. So then you have your tokens, and then we can now trade them. So this is the Truffle system here. There's the name. We've created the smart contract on Ethereum, and we're just asking it how much. And it just happens that the person who created the smart contract has all the tokens and can now move them on. Many ICOs say that you can't trade them for a year. So you'll maybe receive cryptocurrency or ECR20 tokens, but you are now locked in for, say, a year before you can actually trade. So you can add in all these extra features that would define that you're not allowed to move them on, you're not allowed to sell them with a certain amount of time, and so on. That's all built into the smart contract, which is actually created for the token. Okay, so we can see here that it's this account here has all the cryptocurrency on that Ethereum infrastructure there. It doesn't have to be public. It doesn't have to be permissionless. It can be even in a permissioned. You can run it locally within your own ecosystem. Hyperledger Fabric is one of the ones that many companies are now using, and that's a permissioned blockchain, and only the organizations involved within outside the infrastructure are allowed to get access to that. And with its Ethereum, it's open to the whole world. Okay, so some currencies have done very well and are worth a lot, other ones not so much. So here's an example here. Let's say we created a new healthcare system for Scotland, and the NHS or the government goes and creates a number of tokens. In this case, we've created 1,000 of these, I can't remember why I called it that, school tokens. So they've magically created 1,000 tokens. And what they say to everybody is that we'll set up a fiat exchange for you. So let's say the Scottish government could say we'll set up a fiat exchange and we'll make sure that you can convert the cryptocurrency back into real cash. So they have a reserve set aside, and then whenever anyone wants to cash out, they would cash out into a fiat currency. So here is the allocation. They've decided for the whole year that's going to be the number of tokens. So then we create a smart contract which would define what the services were, and then when that was implemented, then in this case Bob Care gets 2.5 of these tokens, because he's implemented something in the smart contract, and then automatically he gets the tokens. He can then cash out whenever he wants into a fiat currency exchange. But what about if I have a token, I've just bought a car, and maybe I want to hide the details of who I bought it from, what the value was that I bought it, and so on. Well, luckily, people are working on this, and this is the new standard for ZK ERC20 tokens. And in this way, they anonymize the actual details of the tokens, but they can still be transferred. And if you're interested, that's the way that it does it. The slide's gone now. So how do we keep our tokens? Well, it's going to be a problem, because if you put them online, there's a good chance they could be hacked. So there's been many recent examples of bad practices in exchanges where people have kept the wallets and so on, and then the companies have kept copies of the private keys and so on. So you need to make sure that whatever service you use, that they're not taking a copy of your private keys, whatever you do. If you can, you store your tokens on a hardware device such as the Ledger Nano. It'll cost you $100 or so. Great investment. And I think it supports 24 cryptocurrencies, and ERC20 tokens go on in there. This other one is highly recommended. It's got a 12-digit code, and you can disconnect it from the internet. So whenever you need to get access, it will do that, and it gets you to write down your 12-digit code. So you've got to watch, because if you lose that, then you've lost your tokens and so on. This one here is highly recommended, and it's all done online, but your browser does all the crypto. So nothing, hopefully, is ever stored on their server. If it is, then worry, and especially don't download any wallet that isn't coming from a trustworthy source, because it can pretend to be a wallet, but it actually can take your cryptocurrency away. And it also, this one integrates in with your Ledger Nano for that. Okay, so let's look at, so that's the perfect scenario. It's all done on the blockchain, it's all trustworthy, it's signed by your private key and so on. So let's look at where we are now. And many developers use JWT, JSON Web Tokens. What's JSON? Yeah, just simple notation, really simple way of storing attributes. I have a name for it and a value. That's all it is. There's nothing fancy about JSON. It's just a nice way to pass data between two systems and for us to share attributes and names. The structure is very simple. It's got the brackets and the comma and the colons and so on. It has attribute and value. That's all it is. And most systems are now moving towards using JSON as the way to transfer objects from one system to another. So with a JWT or a JSON Web Token, JWT, what we get is a token like this. So the token itself has a header, and the header defines what the hashing method is that we're using here, what the signing is. So we can either use HMAC. HMAC, as you remember, is a hash signed with a secret key. Or we could use RSA, where we could use our private key to sign it. Obviously, that's best if we can do that. And then what we have is our main payload. And we have certain public ones that are defined. So we have issued to, issued at, expires. And it's in Linux type time, so you have to convert that into a date format. Typical time, do you know, to expiration that you would grab? What do you think? Seconds, minutes, hours, days, weeks? 1 hour. Well done. Excellent. Typical is 1 hour. So you now have 1 hour of a token which could then be used across your whole systems. The damage that somebody can do by stealing a JSON token is phenomenal. And the way that many systems are set up is that you have admin or others, and if they get the admin token, they can be into all of your systems almost in an instance. Okay, so we have our basic JSON data here, and then eventually we have our signing here, and that, in this case, it's HMAC SHA-256. We take a SHA-256, we apply a secret key. So that's the secret key that your organization has. If somebody leaks that, what will happen? Let's say an insider leaks that secret key. What's going to happen? Yeah, so they can generate whatever tokens they want. It's happened in many currencies. You're at risk because that is a magical signing. If you can sign with RSA, of course it's easier to do that. But then if somebody gets this, then all of your tokens are now going to become valid. Imagine if it was Google or Amazon or something like that, or Microsoft, that somebody managed to get the JWT signing key. They could create whatever they wanted and get authorization immediately. It's the biggest expense of any security problem is a breach of the trust framework. I've said it a few times. You wouldn't believe the amount of money that it costs to flush out bad signing keys, to roll back all your software, to tell all your customers that they can't trust your software anymore. It's a horrible, horrible thing, and it will cost a reasonably large company hundreds of millions to clean it up. So if you're a bank and this happens to you, you're in big, big trouble. You're in danger of even being closed down because you can't trust anything that's been signed by certain things. So make sure you always limit scope of anything that would be accessed. You might only want to give authorization for a few minutes and then revoke it, but you need to have a revocation process so that tokens can't be stolen. And it needs to be tested. So, sorry, that just let me make sure that just needs to, just let me make sure that now gets built in. Okay, so that's what it looks like. That's what we'll build in the lab today. That's a token. Haha, I bet you didn't think it looked like that. It's a really boring format for it. But why do you think they use that format? It's base64, and it's URL friendly. It's got none of the horrible characters and spaces and stuff like that. It's URL friendly. You put it through a base64 URL friendly encoder and decoder, and you can pass it quite happily in the GET or the POST. So basically, most of our software is moving towards RESTful web services, GETs and POSTs. So we're going to have to be sending across tokens like that. Can you spot a character that appears a few times in there? I know all the other characters appear, but is there something? The dot, yeah. So there's the dot there and the dot there. Okay, this part is the header, this part is the payload, and this part is the signature. Okay, so look for the 3 dots, and you'll be able to pick off each bit from your token. And now your browser just receives that. And then what it does is it decodes it and has a look at your attributes and said, yeah, you're admin and you're in for an hour, and hopefully your systems will check. You wouldn't believe the number of times they don't check, and they'll let you run wild. They don't time out and so on, or they issue you tokens that are almost infinite amount of time. So make sure you check your systems as the JWT token moves around all of your systems. Because these days you're hopping from Node.js into Python, into Java, and your systems are changing all the time. It's a hybrid infrastructure that you have. Okay, so that's what it looks like. You have your payload there, that's that bit in there, and then you have your hash in there. From that, it's a 256-bit secret, and then that gives you the basic rights onto the system. So I use Postman extensively. I highly recommend it as either use your Python scripts and so on, but I typically use Postman. Postman is an amazing application where you can actually just call up your web service and pass parameters. What often happens is you get your token passed to you, and then you grab it, and then you post it back in. So in the authorization of the GET field, you put in bearer and the token, and you put it back in. And you wouldn't believe how many systems, it's a dumb protocol with GET and a few headers. You wouldn't believe the number of systems that you just go into Postman, grab your token, say from Google, and then you just use Postman and you're into another system, and it's as easy as that. And you don't have to go through all the tools and stuff like that. That's your first protocol, is the JWT, the tokens. Go for them first, because they are the ones that tend to have not been tested, and the development team didn't care about security and just wanted to get it all working with single sign-ons and so on. Okay, so I highly recommend Postman. I use it all the time, and I interface with the Microsoft APIs and so on, and you don't need a browser. Everything can be done in there. But you can do everything with Node.js and Python if you require it. So let's look at the disaster area that's OAuth 2. OAuth 1 was a pretty good protocol, and it allowed us to be able to have a token that we could use across different systems and so on. And then somebody, and some of the people who created the new protocol actually said, well, it's nothing to do with me. So they kind of walked away from it. But its adoption has been massive because developers just love it. It's an easy integration. It works fantastic. Crypto, no. Signing, no. It's a complete and absolute disaster area. And everybody in the industry knows about it, but they keep quiet about it because they know that every corporation is at risk of these things. So it really comes about, don't we just love federated ID? Who uses federated ID for the logins? Do you use Facebook? Who uses Facebook to log in to some of the, oh no, of the federated identity providers? Who uses Twitter as the, I use Twitter. Anybody else use Twitter to log into systems to provide your ID? Nobody else does that? LinkedIn? You don't do it at all. Well, one, maybe 1.5. Facebook? And do you trust Facebook?
Okay, so I trust Facebook security more than I trust these random sites that I might use security.
I completely agree. I completely agree to that. I don't want to store my password on these little sites.
Also a side thing. So Virgin Media, I was calling them up yesterday, and they asked to verify my account by plain text characters. So they had, so the customer support guy had my password, but it was like certain characters he asked for it. So I'm like, wait, so you guys are storing my password in plain text? He's like, no, but I can't see it. But I'm like, no, but it's in your database as plain text, and then some service gives it to you for characters.
Yeah.
So am I right that if they, even if they can see the original, if they can see even some of the characters, unless they're encrypting every single and hashing every single character of my password, then it's in plain text?
It must be resolved back into plain text somewhere because you would normally check your hashes by just doing the same thing.
Yeah.
So you're correct, they're doing a reverse, which means there is some place it would need a massive computation power to be able to do that in real time. So you're right, they're there. And that's the worry. And at least Facebook, Mark Zuckerberg is kind of taking security. They know that
They were called this the other week, a couple of weeks back, with plain text.
I know. Yeah. So the industry is a shambles. Auditing, compliance regimes, PCI and so on really haven't worked. Auditors go in, yeah, you're hashing your password, that sounds good. They don't ask if it's bcrypt or so on, and just a mess. But increasingly, we will trust one identity provider for us. We try to log into a service, and we get told these are the identity providers that we trust. We get a token from them, then we pass that token into the service provision, and that's great. That's what federated identity was all about. Tell me what the problem is apart from the security problem.
Single point of failure?
Single point of failure? Well, it's a bit better because you're now relying on many ID providers, so you're not providing your own system necessarily. So it's probably better, but you're right, if it's just one, like ping. That's right, yeah. So that if the service is gone, then you are snookered from there. The biggest problem with the Facebook login. What's the biggest problem with using Facebook as a login for another system? Let's get into the NHS.
They have that data.
Oh yeah, I'll be your ID provider. Please come to me, because they're not charging you here. And they go, well, where's the business model in this for you? Okay, I know that you're now going to Boots the chemist and so on. So I'll send you some medication for that problem that I now don't know that you actually have. So the ID providers are typically ones that have some business case in knowing you and so on. So some people have tried to anonymize that. .NET 3 and Microsoft tried to do it, but it just didn't take off. And now Facebook are in big trouble because of all their APIs, and they're trying to lock them all down now, and they don't want to be the ID provider of choice and so on. So it's a big hodgepodge. You've got to think that an ID provider is an ID provider. So it's a VeriSign or somebody that you trust to be an identity provider. It's the post office or your bank. It's some company that actually just concentrates on identity, looking after you, and doesn't have other business interests that might relate to identity. So that's a federated model, and it's a model where we can gain rights from our identity and our roles and so on, and we create our tickets and we give it to our infrastructure. So the way that OAuth works is that you go to your service provider and you say, I want to log in or I want to gain access to something. They then define an authorization and tell you to go to your authorization server. You then can pick, say, Facebook, Twitter, GitHub. Do you trust GitHub? You know who it's owned by now? Microsoft. So I kind of trust GitHub, because if they get into trouble, then people will migrate off their system as quickly as they can. So GitHub know that even a few second risk, people will get their code off in an instance onto something else. And I'm sure there are a lot of disaster recovery plans that say if something happens with GitHub, then we're off and we scrub it and it's away. Because all of your code, all your documents now are all stored in GitHub. Your scripts, your Cisco configs and things can be backed up there. So you go there and you log in to GitHub in some way, or you might use multi-factor. You get your token back, and then it goes back to your service provider. So all you have to do is, on here, is identify your application name, the website name, and what's called the callback URL. So the callback URL is, if you manage to get in here, it's going to call you back to a web service somewhere, and it's going to pass the token in there, and everything will be fine. And this is horrible. This is really horrible, 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 horrible. So please don't take it that I'm endorsing anything about OAuth 2 here. I am not. It's rubbish. But you need to identify the problems. It gives you a client identifier and a secret, a client secret. That's it. That's it. There's nothing else to it. And did Cambridge Analytica and all these other companies do that? Of course they did. Once you open your APIs, then you're opening up a whole lot. Twitter APIs, LinkedIn APIs, that's what you get at the end of it. Don't put that in your code. A standard hack is to look in GitHub and to look at everybody's JavaScript, and then you'll find their Amazon logins and their OAuth 2 identifiers. I think there was research recently, a massive number of GitHub sites had embedded secrets in them that somebody could then go and abuse the API. It's horrible. So just watch what you're putting in your GitHub. If it's a public GitHub, even if it's private, people in your own company can see all your API secrets in there. Okay, so this is what you do. So I've logged into a security site, and it's now asking me to log into GitHub. So we send this as a string. Look at that, because there's the client ID sent as a get from there. And how do I know that's a get? It's in a URL, and I pass parameters. So the ampersands to differentiate the parameters. So we take our secret here. So if I'm just using Postman, or if I'm copying and pasting even, say with Python, I just create this again, I pass in my secrets, and everything's fine. So then I now get an authorization code from the system. What I get back is my token. So the token will then be contained in here for my access to the system. That's what the token looks like when I get it back, and you can see here it's horrible. Where's the crypto, and where's the signing, and where's the encryption, and so on. So it's a horrible, horrible, horrible mess. And then if I want to pay it back, if I don't want to use Postman, I'll just use curl, and then I'll post the token that I get here back in with the bearer for the authorization, as we saw before with Postman, and I'm in. So this is me posting back my token, because the token is just that token that we saw before. And then this paper came out. Everybody knew about it in the industry. I knew the problem. So this paper was published, and signing into 1 billion apps effortlessly with OAuth 2. It was that easy, and they identified the problem. 41% of these apps were open to abuse from an OAuth playback attack. It's a horrible, horrible thing. Luckily, the industry has been looking at this, and guys from Microsoft and Google have came up with this new specification. And listen to this. What you do, and tell your developers, if you are working with developers, or if you're a DevOps or DevOpsSec, I don't know, or if you're an architect, what you get is your token, and then you need to bind that token with the session. You need to be taking something about the TLS session, something about the IP address, and binding it in with the token to make sure that that token cannot be used in someone else's session. So you bring in server variables, session variables, you bring in something around the TLS integration, and if you can, you bring in the trusted execution environment inside the device to make sure that you bind that from there. So it's this paper here, or this standard here, that's been proposed that actually takes into account this token binding. So we don't just have a blind token, we have some way to bind it to something. So if you're interested, you can read that paper. It's a great dissertation topic. It is a massive problem for the industry. Okay, so here's me. This is what we're going to do today in the lab. Okay, so you go to GitHub, you will register your OAuth application within GitHub. You all have GitHub accounts now? Yeah, good. You go to GitHub, authorize it, send it back from there. What you get then is this. So we get our client ID and our client secret. You copy and paste that into your little Python script, and then you run Flask. We'll introduce you to Flask today, amazing sort of service that you can actually create your web services and so on. So then that's your secret there. And then when I log into my site, I then get sent here, and it tells me that I'm authorizing through GitHub. I can put my own logo here if I want to customize it. I then put in my details, and with GitHub you can have multi-factor authentication. So it's a much better system than probably than you're using just now for many of your systems. So that's that. Another method, and I highly recommend this way of passing in encrypted data, and it's with what are called Fernet tokens. And Fernet tokens are meant to make it easy to be able to encrypt data between systems. So I go from a web browser to a web server, or from one system to another. I can use a Fernet token, and if you're using Python or Node.js or Java, they will all be compatible. So the way it does it is that we have various fields, version number, timestamp, salt, ciphertext, and it's signed. Okay, it's signed with an HMAC. Not perfect, but it's at least a way we can actually do it. And the great thing is that we can use multiple keys. We can use multiple keys on either side, and we can have a key rotation policy. So today I'm going to be using one key, and then tomorrow I'm going to use another key, and so on. So I create a bunch of keys that I'm going to be using, and you create what's called auto-keying. So auto-keying is that Bob and Alice have generated 1,000 keys. And you don't know on which day, maybe every week, they rotate their keys and they go through them all and then go back to start again, and then they might retool. Eve is confused because she's trying to hack one, but then the next day the encryption key changes. So it looks like this, and we use a key derivation function to take your password into the encryption from there, PPK DFS2, and these are the bits that we have, 128 bits for salt, that's great, good salt in there, and then we have the H mark at the end, which is verifying the whole thing. We have a secret passphrase that we verify, the H mark, and everything is fine. So here's an example here. So I've taken my password and I've generated this key here through my key derivation function, and there's the cipher. And the cipher, you've got to count. 67 is the version, timestamp there, IV vector there, and basically just gets chunked all together, and we can see there's the H mark at the end there. So we take our hex stream and then we just chop it up. As you'll see with our Python, it's quite easy to do that with a little colon, square brackets. We chunk it off. And in this way, it's a URL safe, because it's just numbers, or we can convert it to base64. We pass it through a web server or something like that. It's a friendly way of passing encryption. And hopefully, once we decrypt, we'll get the message back again. But the key is to know the password to be able to give you the keys and the signing. This is the code here, if you're interested, for it. There's the key derivation function going on there, and there's the Fernet import that we've got, and it should hopefully all work. And you just say to your dev team, just do it. It's just, there you go. There you go. Not too difficult, is it? But it'll get in the way of, no, look, it's not difficult. Just a few lines of code, Node.js if you want, or Java, whatever. It's not too difficult to create the encryption here. And it's just like easy, because you just have a secret on one end, secret on the other end, and it's all encrypted, and you'll pass it through as a hex string in there. So this shows as I remember, this is looking at different parameters for a key derivation function from them. Okay, so this is the run that we'll get hopefully in the lab today. Gives you timestamps, which is quite good, so you can verify your system. Okay, that's what it normally looks like when we convert it into a token. We put it into base64 URL friendly format. So that's typically how we would see the token there. And I'm using a key here, and hopefully I'm able to decrypt from there. And key rotation is very important, and many systems will not stick to the same key all the time, but you've got to try and remember the ones you've used in the past. So key rotation has a policy that I change my key every week, and then what I do at the very end, I now have to go back to the start again, and so on. So you could have 1,000 keys that you use as a batch. It depends if you're storing data or not, but you could re-key at a certain time once you've went through the whole pool, and then go back again. But Bob and Alice have got to agree on the keys that are actually used. And it reduces your scope for an attack, because if Eve finds one key, then all the other keys are fine, and then you're going to retool anyway. So this is the example here. So I've got a number of keys that I've used, and then I create the multi-Fernet, which will tool and try each of the keys to see which one will actually work. Okay, so what we'll do is we'll have a break for 5 minutes, and then we'll continue. I'll give you a heads up on Pake. We'll look at Docker and Kubernetes, and then we'll have a little test again. Thank you. Okay, so I'm going to show you a quick method on what I recommend you do for your passwords in the system, if you can. And it uses a zero knowledge proof to be able to prove passwords, but you can apply it into any secret in there. So the method is called PAKE, and it comes from the problem, as we've seen, that in your hashed password database, you've got that, and as we all know now, the salt was there, so all we have to do is run hashcat. We know that people put uppercase letters in the first, that's you. I did an event last week, and I said, who puts it first? I'm going to do a mind reading act. That's what I'm going to do at the Edinburgh Festival. I'm going to do mind reading. And I said, who puts the character first? And I think it was almost 100% of the audience said first character is uppercase. All of the audience said they used one uppercase letter, and all of the audience said they used the number at the end. Hashcat knows that and can focus, and you're massively reducing your space, and if you're using that for your key, then you're in big trouble. So the problem that we've got is that hashcat might do 10 terahashes per second, and so on. So virtually every password up to 10 characters can be wiped off. And we don't need rainbow tables anymore, and rainbow tables aren't very good anymore because nobody, hopefully, doesn't salt, but as we know, some people do, like as was mentioned earlier, don't actually use salt or might just store the plaintext. But if they store salt, then hashcat can very quickly go through with brute force with a rule and very quickly crack that. Okay, so we need to move away from that type of approach. So SRP is one protocol, and we've implemented it in a few systems, and it works very well. Quite complicated, Python scripts are there, and so on, but the good thing with SRP is that there's a stored secret, which is just a nonce value. Alice passes in her password through SRP, and then we end up with the same encryption key, and Alice has proven her password and can now log into the system. So it's certainly there, and you can implement it on different systems. The Spake password system is quite interesting when there is a secret on either side, and Bob and Alice want to prove to each other that they both know the secret from there. So in this way, they exchange using the Spake protocol, Spake 2, and they can prove each other know a certain secret and end up with an encryption key which can then be used for authorization. So that's that method, and if you're interested, there's the maths behind it. I wouldn't ask for anything on that, but it all works through this magical stuff of, as we all know, elliptic curve, amazing, fantastic system that it is. And so you prove passwords, and where you can actually do your hash, and then delete. So you delete the hash with the salt initially, and then use Spake 2 to be able to transfer the values over, and you don't need to store the hash value anymore. So Bob and Alice just need to know the secrets that they have, and Spake will actually do that for you. And there's another system called Opaque, which is now being promoted. And with this, it's a bit difficult to outline, but Bob has a salt and Alice has a password. And Alice can't tell the salt and Bob can't tell the password. It's done with what's called oblivious transfer protocols. I can get the salt to Alice in some way, and Alice can get the password to Bob in some way without either of them knowing what it is. It's called oblivious transfer, and at the end, they come up with the same secret key. And the good thing is that Alice, who might be a hacker, hasn't found out what the salt is that Bob actually has. A lot of protocols will pass that value, and at least one of the parties will know the secret of the other side. So that's an interesting protocol. I've got some code if you want to see it. That's how it all works. Uses this oblivious transfer method to blind things. It's like when you buy a ticket at the Edinburgh Festival, say in the Usher Hall, you book a ticket and the theatre can see exactly where you're sitting. An oblivious transfer method means that I can still buy a ticket and the theatre can't tell where I'm seated. But I can go along and I show them that I've actually bought the ticket and here's my seat. That's an oblivious transfer that the other side can't tell what the other side has, but you can make sure it's all trustworthy. Hopefully that makes sense. Okay, so that's another method. That's the kind of things you might look to implement in your systems. So let's look at the wonderful little Docker. So Docker is a company, okay? Docker is a company, and they have their own containers and images and so on. There are other companies around, and if Docker goes under, then there are other companies that can be used. But do know that if you rely on Docker and the Docker images, then you are relying on them having those images around. So it's a risk to your organization. So what we have is that we have bare metal. So bare metal is when we run our services on a bare metal machine. Okay, so that type of system is obviously going because we're running on, I don't know, 16 cores. We've got a terabyte of memory and we're ticking over with a little web server. So it's a waste. So we moved to the cloud where we could actually, and Hyper-V and so on, where we can multi-thread our operating systems. So we have our hypervisor, which allows us to be able to switch between operating systems. So the hypervisor is just there to put our program on the processor and take it off and keep it in memory and to remember the state and so on. So that's the way the cloud works. We can have a lightweight hypervisor like VMware, which has a very thin layer and interacts with the bare metal, or we can have something like VMware Workstation or Fusion, which will run our operating systems on a more heavyweight system. So that's kind of the way that the cloud has been created, but you've got to say, why do I have to run full Windows 2008 just to get a web server? So the whole reason behind Docker is that we can actually get rid of operating systems and all the baggage that comes in whenever we install operating systems, and we create little containers. And what we do is we build an infrastructure with little small containers that all work together in some sort of way. And why do we need port 22 to run an SSH? Why can't we have a configurable port that we just script and move it to port 579 and then have multiple instances? So the whole Docker containerization is that we can create generic instances and then we containerize. So we build our applications by saying we need a bit of this and a bit of that, and we need this network, and we need that to talk to that, and let's move it to that IP address, and now let's spin up another instance, and let's cope with the work balance. So the way that's been pushed in many companies now is this. We start off with our task, we develop the application infrastructure, we then containerize it with Docker to find out what we need to build it, and it's typically done in Amazon or Azure as an infrastructure. And then we use Kubernetes to be able to do all of that magic, the security and the load balancing and the orchestration to get everything up and running and so on. So this is now really the roadmap that many infrastructures are moving towards. So Docker looks like this, okay? So we have Linux or Windows or your Mac, and you install Docker onto it. So it exists as a Docker engine, and it sits on top of the operating system. And you say, well, that's fine because my CPU is sitting at 5% all the time. So if Docker takes a little bit of an overhead and what it does to go from here to here, that's fine. I've got lots of processing power to deal with. And processing power is inexpensive in the cloud, really, because you hire a server for an hour and you pay for it. Some companies are moving towards a per second. So if you look at serverless technology, you pay for the amount of time that you are using as a CPU, and you lose it. So you can build Docker here, you can build Docker into your hypervisor and so on, but this is the kind of older way to do it, and we've got these big operating systems and so on, and you've got to wonder, why do we need operating systems? Could we build the security into Kubernetes to make the security work across, rather than for each machine having its own read-write access and these horrible technical security attributes? So in Kubernetes is interesting. So I think it was built by people who had done orchestration and load balancing in the industry for many, many years, and decided that they needed to create a new infrastructure. So with Kubernetes, you've actually got a system where the users can come in, and then Kubernetes will automatically orchestrate things, get things set up for you, allocate IP addresses, allocate ports, spin up, spin down, log, and so on. So it's an amazing, you'll find many jobs in this area. It's a big thing just now, and I think it's even bigger than the kind of Docker world. And it'll be Kubernetes that will probably drive a lot of the industry forward. So this is what a Docker file looks like. This is what we'll implement in the lab. I've just copied it from somewhere. Not much to it. So that just downloads the Docker instance for Ubuntu 16.04. So watch whenever you download in versions of operating systems and components that you log the version number. And whenever you roll out new ones, you check that it all works together. So we're quite happy with that version. It will go to Docker. It will download automatically from the Docker site the instance onto your machine. So it now resides there as a little Docker instance, and it can now be deployed multiple times. If we want 100 SSH servers across our whole infrastructure and load balance them, then Docker can actually say, let's have them all, and then Kubernetes can come in and say, well, they're all going to tie together with one port, and they're all going to use different ports in there too. And then we can run commands inside the Linux environment. So anything we do, we can script it and run commands that we know are working. And in this case, we're adding the password in here for the root account, and we're setting up the SSH service and running a few commands there, and this starts it all up. And you then create, and I'll show you the setup. So we create in there, try and find it. Yep. Okay, so this is our Docker file. We create a Docker file in our folder that we're going to create, and then we build it. So we have a build -t and then the name of the folder, and it'll go ahead and it'll compile almost all of these commands. So I've only shown step 10, but then it will then build that as an instance as for us. Okay, and then it gives it a tag that we can then use later on when we're referring to that Docker component. If you ever want to see what images you've got on your machine at any given time. Use the Docker image ls, and in this case we can see that I've downloaded the Docker component here, and it tells me the ID and so on from there. When we run it, we then run with a Docker component like this and give it a name, because we can create multiple instances. In this case, our running instance will be called test SSHD. We can create multiple ones if we want. We can also have a -p where we can map a port that we've defined. So the port will be defined in our service 22. We can remap port 22 to port 995 or something like that. So within the command line, we can remap something that was a port in the service, which is 22 in this case, to another TCP port. We can also define it as an IP address, so we can actually put it, give it its IP addresses and allocate all the network adapters and push it to wherever we want from here. So then you can see here, that's us creating it, and then I can run it from here, and I can allocate the port that it's going to be giving. I then go ahead and I log in to my Docker component. So it's now going to be sitting at this port. So I'm just using SSH to log into that. From there, I could do, what's the command that you use to find out the ports that are open on your machine? Netstat. So I could use Netstat and have a look to see the ports, and you'll see port 32769 will now be open, and it's ready to be connected to by SSH. And because SSH defaults to 22, we put the command line option to move it to the new port that we have for our Docker component. Then when I'm in, you can see here, I can just go ahead and it should work for you. The password that we set here should all be set up when we actually created it. So this is me in now. I'm in my Docker component, and I'm in SSH server, and I can do whatever I want in there. To have a look at the running instances that we've got, we just do Docker PS, and it'll show everything that's actually running. Remember, on a real-life system, you could have hundreds or thousands of Docker components, and Docker will quite happily run on a 16 gig laptop. So if you were to run like some of your complex infrastructures on VMware, you'd probably run out of space ESXi, memory very quickly. In Docker, you can probably have hundreds of these components all running. It manages them very well from there. Okay, and then when we're finished, we can actually stop the container, and then when we want to get rid of it, we just remove it. And if we want to get rid of the image on our machine, we just do image rm. And then there's yet another markup model, .yml. And for this, you can actually script exactly the Docker component itself. So I've just taken this one. It's a standard one that others use. It implements an open policy for web access, and for this you compile that in with the Docker Compose. So with the Docker Compose, you compile your script, and then you'll create your instance from there. A typical thing that you do in Docker is that you don't actually go into it, but you might want to configure it with some parameters. You just use the curl and then do a put, a get or a put, as we saw before. And the curl allows you to upload, in this case, a file into your Docker component here. So that's obviously a weakness, because if you don't use good authorization here, a malicious entity could get in and upload stuff. So again, watch your dev team. They'll have lots of little things for loading up the Docker component once it's all running, and they forget about it, and actually it leaves it open. that somebody discovers this, they can actually upload configs and stuff like that. Okay, and then again, we just test it with our little curl. That should be curl commands, sorry. Little curl commands. We don't need to use a web browser for these things. We could use Postman or we could use curl commands. Okay, so in the lab today, we will do that. So in the lab today, there's quite a lot to do, but we'll take you through JWT tokens. Try and finish the lab sometime. We'll do some Fernet tokens, and then on to the wonderful world of OAuth 2 and the disaster area that is. I highly recommend Flask. It's a fantastic, you can build really great applications through Flask without ever going near Visual Studio or anything like that. So we'll set up that, and then you'll see how easy it is. So we want you to set up a GitHub authorization infrastructure, and then authorize yourself through your GitHub account with the IDs, and look at that. Then the last one, we'll have a look at how we can set up a Docker. So I apologize, Docker isn't installed on your Ubuntu machines. So you're going to have to install the components for it, but it should be fine. Once you've went through this installation, Docker should be set up. If you want to run it on your Mac or your Windows machine, you can't run a Docker Windows machine, but who needs that anyway? You need Windows to run Docker Windows, I think, but everything's all Linux now anyway, so I wouldn't lose any sleep over not being able to run Windows instances. You need a license anyway, you do know that from them. Does anybody have any questions about that? It's a fantastic, you have so much control and you don't have to run whole VMware cloud infrastructure and so on. You could set up your own little environment with all your servers and stuff like that, and run it in a VM somewhere, and it'll be fantastic. And you stop and start things. Okay, right, good, excellent. So let's. I don't have a lot in the test, but let's give it a try anyway. So let's go ahead, and if you get connected, so it's 8602. I didn't spend too long on this one. I apologize, but we'll see who's remembered what I went over. Good. Yeah, 4 question marks. That's good. Like cats, good. All right. So, are we ready to go? You got that? Got that? Good. There we go. Right then. Okay. Do you have any cryptocurrency? I won't come after you, I promise. Do you have any? Who's got cryptocurrency here? Who's got you? Oh, you don't have to put your hand up. So yeah, so three people have got some cryptocurrency. Anybody thinking about it? If you bought it last week, for goodness sake, you know, I did tell you to buy it last week. I didn't. You know, buy Bitcoin. I said that was the last thing I said. That's a shame because it's went up $1,500 at least. It's just crazy. I don't understand it, but I don't sell cryptocurrency, by the way. I have no cryptocurrency. Okay, so 4 people have got cryptocurrency. But stick your hands up. No, 1, 2. No, okay, that's good. Right. So that's interesting. I just thought I'd ask that one. Okay, so get yourself registered. Yeah, I like that one. Okay, ready to go? Good. Right then, okay. What type of token does not have any security inbuilt into it? GWT, OAuth 2, or Fernet? I'm expecting you to get all this right. Oh dear, some people that said I obviously don't stress things enough. I only said it about 1 million times that OAuth 2 is a disaster area and it should be shut down. And I did show a research paper that said 1 billion apps, 41% of all the OAuth. So we'll play back the lecture, so you can't see that. I didn't say that. Okay, so good that 16 out of 19, I think it is, got that one right. So let's see who was the fastest finger for that one. Oh, Clementator. Bibbies and Spartan and QWERTY and Wartooth and Liam. Oh, much the same. So there's not going to be much between them. I won't show the ones who did get that one right. So that's it. So Clementator is doing well there again. Okay, get ready. Which platform are ERC20 tokens supported on? Bitcoin, Hyperledger Fabric, Ethereum, or IOTA? We do a lot of work around IOTA. If anybody's interested for dissertation projects, they have what's called a Tangle, and it's Ethereum. So 13 got that one right there. So we'll just see how we're getting on. Much the same. We've got Corba. And what does that say? Who did that one? That's an S, I think. ... No, O. That's an O in Morse code. Somebody thinks in Morse code, which is good. So Clementator still in there. QWERTY was the fastest that time. Hashberg. Was in there. Oh, sorry, did I go past one question there? Is that question 3? Okay, get ready. What's the name of the smart contract compiler? Is it Truffle, Trifle, Custard, Jello, or Cake? Makes you hungry, doesn't it? Dough. Okay, who said Jello? Who said Jello? Oh no, who said custard? Yeah. It's Truffle, and I've mucked up. That's bad. I'm so sorry about that. So I just did this before the class. None of the options are correct. It's got vanilla slice. Okay, that's. So it's called Truffle, by the way, and Truffle was right. So I really apologise for the 10 people who got that one right. Who got that one right? Go on, tell me. Good, excellent. So mainly over there. Right then. So I'm sorry about that. So hopefully this one will work. Okay. It's a disaster today. I'm sorry. Is that going to be the same question again? How are Fernet tokens signed? RSA, elliptic curve, HMAC, AES, or SHA-256? Don't know. Yeah, that's the other option there. And it's HMAC. Yeah, at least I put that one in correctly. That was me talking about trustworthy systems today, and you can tell I'm not quite trustworthy when it comes to doing the tests, so I apologise for that one. Right then, so that was hardly the most challenging of tests, and it was a bit of a disaster. But let's see who won that one there. And Spartan Green again. Oh, Clementator will be Clementator. Yeah, it looks like Clementator. Yeah, it was. Yeah. So that was really well done. Yeah, I'm sorry about that. I mucked up. Okay, so hopefully I've given you a heads up on the way the industry is going. Most of the security problems are now caused at that authorization higher level layer, given too many rights to someone and to be able to play back things. So hopefully you should now, once we do the lab, understand what a JWT is and possibly how we use tokens to be able to create single sign-ons and things like that. Okay, well, thanks very much. I'll see you in the lab in about 15 minutes or so. Thanks very much.